Hey guys, we're just going to review what we've learned so far about radicals with indexes other than 2, as well as learn one or two new things. Alright, so firstly, a reminder of how to simplify a radical is we're going to take the prime factorization of the radicand. The radicand is the number inside of the radical. In this case, we're going to have 32. We're going to split that into 2 times 16. I like to factor out 2's because it's very easy to determine if a number is divisible by 2. Until we can't do that anymore. So these are our prime factors. So this will become 3 cubic root of 2 to the third times 2 to the second. And we're splitting this up on purpose such that at least some of the factors are divisible. They have an exponent that's divisible by 3. So this has an exponent that's divisible by 3 because that's our index. So that means it will come out as a 2 to the first power. In other words, we divide the exponent by the index, and everything else stays where it is. And we're just going to simplify. 2 times 3 is 6. This is the cubic root of 2 to the second, which is 4. We're going to do the same thing for the 5 cubic root of 40. And the idea is we couldn't add these before because in order to add two radicals, two things have to be true. You actually need to have the same radicand, which they do not, but they could after simplifying. They also need to have the same index. Now these have the same index. So let's try and simplify these as well. This as well. So 40 is going to become 2 times 20, which is 2 times 10, which is 2 times 5. So we actually get 2 to the third times 5. So we're going to rewrite this as 5 plus 5 cubic root of 2 to the third times 5 to the first. This again is divisible by 3, so we're going to because that is our index. So we're going to bring that out as a 2 to the first. Everything else is going to stay the same. 5 cubic root of 5. So this is going to become 10 cubic root of 5. And you'll notice that after simplifying, the radicands are still different, so we cannot combine these, so these are unlike terms. So this is the simplest radical form of that expression. Now if we look at this second example, we'll notice that we have the same radicand, but unlike the previous example, we actually have different indexes. So similarly, these are unlike terms, but perhaps they'll simplify so that they are. So let's just briefly try to simplify these. 8 is actually going to, in factored form, become 2 to the third. We do the same thing for the other one. And you'll notice that because we have different indexes, even though the radicands are the same, this one will be able to divide by this index, but this one's not going to be able to divide by this index. And even if they did, they wouldn't leave the same things over. So this is going to become 4 times 2 to the first with no radical left over. This will not change at all. So this is still 2 fifth root of 8, and this becomes 8. So we have 8 plus 2 fifth root of 8, which are unlike terms, so we can't add these, but this is the simplest radical form of this example. Now, we also talked about multiplying two radicals. So we're going to use the same two examples. We're just going to change the addition to multiplication. And the general rule is that you multiply the coefficients and then you multiply the radicands. Now, it would be easier to do this if we simplify them first. So we'll just take the answers we had from the previous problem. So that was 6, here let me just copy and paste, 6 cubic root of 4, 10 cubic root of 5. All right, so we can multiply the coefficients, which is 60. We can multiply the radicals, which is going to be the cubic root of 20, and that is this simplified. We should check and see that cubic root of 20 doesn't have any perfect cube factors, so we'll split 20 into 2 times 10 and 2 times 5, and there aren't 3 copies of any of these, so this isn't going to simplify any further. Now in the other example, we have different indexes. Now that's going to matter So there's a rule for what to do when you have two different indexes, and it's to try and make them the same when you're multiplying. So the rule is going to be that any number to the a power and a root of b will be equal to x to the a over b power. All right, so that means this is going to become 4 times 8 to the 1 over 3 power, because it has its own exponent of 1. Now the 2 stays the same as well, and this is going to become 8 to the 1/5 power. Now we're going to try and make these fractions have a common denominator so that they become a common index, because again, the indexes became the denominators of these fractions. So what we're going to do is we're going to multiply the first denominator, or the first fraction, by 5 over 5, and the second one by 3 over 3. That way they'll both have a denominator of 15. So this is going to be 4 times 8, 5 over 15, times 2 times 8, 4 over 15. I'm sorry, 3 over 15. I got added by accident, excuse me. And now we're going to convert them back into radicals. So this is going to be 4 15th root of 8 to the 5th power times 2 15th root of 8 to the 3rd power. We're going to multiply the coefficients. So 4 times 2 is 8. This is still a 15th root. We're going to multiply the radicand, so 8 to the 5th times 8 to the 3rd is going to be 8 to the 11th. So at this point, we're actually going to multiply. It would probably be easier for us to just, we have two options. We can either multiply this out and then find the prime factorization of this, or we can just find the prime factorization of 8, which is just 2 to the 3rd. So we're going to rewrite this as 8 times the 15th root of 2 to the 3rd to the 11th, which is going to be 8 15th root of 2 to the 33rd. And this way we'll be able to take out some of our 2's. So this is going to become 8 15th root of 2 to the 30th times 2 to the 3rd. So the 2 to the 30th is going to come out as a 2 to the 2nd. So we're going to divide by the index, leaving us with a 15th root of 2 to the 3rd inside of the radical. So this is going to become 32. That's 8 times 2 times 2. 15th root of 2 to the 8th power. All right, so we can multiply them by changing the radicand to have the same index, and we have to do that by converting them into exponents, and we can do that by finding a common denominator. All right, so there's one more thing we're going to cover today before you might want to print out the worksheet in advance for class tomorrow. We're going to talk about rationalizing a denominator. Now, if you remember the definition of a rational number is a number that can be written as a fraction of two integers, and an irrational number is a number that can be written with a irrational numerator and a rational denominator. So if we look at these two, the numerator and denominator of this fraction, which we could also write like this, the denominator is irrational. Both of these are irrational. So we have an irrational numerator and denominator. So that's not allowed. We're only allowed to have a irrational numerator. So our final answer has to have what's called a rationalized denominator. Now there's two ways we can do this. We can either simplify it first or we can simplify it later. So we'll do it this way first, where we put them inside the same fraction. We're just going to simplify 70 over 50, and then we're going to try and simplify it a little more. So this is going to become radical 7 over 5, because 70 over 50 is going to be 7/5. We're going to rewrite this as radical 7 over radical 5. And I want the denominator to be rational, so it can't have a radical on it. So what I'm going to do is I'm going to multiply the top and bottom of this fraction by the same thing. Specifically, radical 5, because radical 5 times radical 5 will be equal to 5, which is a rational number. The numerator, on the other hand, is going to be radical 35, which I could potentially simplify. Radical 35 doesn't happen to simplify, so this is our simplest radical form of this expression. Now, we could have simplified the radicals beforehand, which might have made this a little harder in this case. So we would have to actually simplify radical 50 and radical 70. So 70 is going to be 2 times 35. 35 is going to split into 5 and 7. So there are no prime factors of 70, so radical 70 is not going to simplify. But radical 50 is 2 times 25 and 5 times 5, which does simplify. So radical 50 is going to become radical 2 times radical 5 squared. So that's actually going to become 5 for the first, radical 2. So this is the denominator and this is our numerator. So let me rewrite that down here. So this is radical 70 over 5 radical 2. And we just want to simplify. We want to make the denominator rational. So when we have a radical in our denominator, we just multiply the top and bottom by the same value of the denominator. So this will become, in the denominator, 5 times 2 over radical, with 140 in the numerator. So this is going to be radical 140 over 10. And we can now simplify the radical in the numerator. And then we'll have our final answer. So radical 140 is, well, it's 2 times 70, 4 times 35. So this is going to be radical 4 times radical 35 over 10, which is going to be equal to 2 radical 35 over 10, which is going to become radical 35 over 5. So there's a couple ways to approach this. Simplifying by putting it all together in one fraction is probably easier than doing all the simplifying and then having to do it again. You might as well simplify at the beginning. Yeah, and that's going to wrap up everything you need to have seen before we start class tomorrow. So if you have any questions, make sure you leave them in the private comments of tomorrow's lesson.